Somehow this class is so calm today, I don't understand. I don't even know if you can hear me because nobody reacts.
I can hear you.
Okay.
Hey, could you go over 2.320?
What was that again?
2.320.
Okay, that's going to be next because this is 2.2. So we are going to answer a few questions from each of the sections that we have. And of course, all those sections are going to be on the test on Thursday. So we have 1 plus x to the 4th dy plus x times 1 plus 4y squared dx equals 0, y of 1 equals 0. So this is the first problem we have, and that's a separable equation. And we need to solve this equation. What are the steps of separable equations? The first thing is separate the variables. So get all the y's on one side and get all the x's on the other side. And typically, that's all the test is going to be about. You get about 2 problems per section. And I think you got 4 of them. That's 8 problems. At least. So here, now we have dy stays here. 1 plus y squared is going to go down. We're going to divide by 1 plus y squared to make sure dy and 1 plus y squared stand together. We are going to divide by 1 plus x to the 4th to make sure that that stands with the dx that is here. So it turns into dy over 1 plus 4y squared plus x dx over 1 plus x to the 4th equals 0. So we divide the equation by those things to make sure that all the x's are together and all the y's are together. Now we can send the x's to one side it goes with a minus sign. That's what you get. Then the next step, you're going to integrate. And right here, that was separate. So you separate, then you integrate for integral of dy over 1 plus 4y squared equal negative integral of x dx over 1 plus x to the 4th. And so here you are going to use u substitution on both sides. On this side, we are going to use u equals 2y because that's 4y squared. Du is going to be 2 dy. So this is 1/2 integral of du over 1 plus u squared equals negative integral And here we are going to have u substitution, or v equals x squared. So dv is 2x dx. So x dx is dv over 2, so that's 1/2 also. dv over 1 plus v squared. And right there you can see that you can get rid of those 2's. So you can divide or multiply by 2 both sides. This is arc tangent of u equals negative arc tangent of v plus a constant. And you can see you have arctangent on both sides, so you can simplify this. If you bring them together on one side, that tells you that arc tangent of u plus arc tangent of v equals a constant. Same as when you have both natural logs, you apply exponential. So here you apply the function that is the inverse of arctangent. You're going to apply tangent on this. And so you're going to have tangent of arc tangent of u plus arc tangent of v equals a new constant. Tangent of c is a constant. So it's a constant that you get. Now, you have this formula from trigonometry. So tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent of a tangent of b. So that's what you can apply to this. So tangent of this sum is going to be tangent of arctangent of u plus tangent of arctangent of u of v over 1 minus tangent of arctangent of u times tangent of arctangent of u of v equals a constant. Now the good news is that tangent of arctangent is just what you have. So that's u plus v over 1 minus uv. Now you can replace u and v by their values. U is 2y plus x squared over 1 minus 2yx squared equals k. Now you can use the initial values. Y of 1 equals 0. That means when y is 0, x is 1. So that's 0 plus 1 over 1 minus 0 equal k. So k equal 1. And that being the case, you take that k that you found and plug it in there. So you have 2y plus x squared over 1 minus 2yx squared equal 1. And because it said y of 1 equals, then you can actually solve for y here. That's going to give you 2y plus 2yx squared equals 1 minus x squared. It should divide to get y equals 1 minus x squared over 2 times 1 plus x squared.
Should we always put it in a y equals form if we can?
Yeah. And this is really, you see, it's a simple thing. It's linear. It's just solving. There's no square root, no nothing. But if the question is having them combine everywhere x and y, then you don't need to worry about that.
In the denominator of the answer, that's 2 times x squared.
1 plus x squared.
Okay, it just wasn't clear.
What does the equation in the first box say?
Where?
In the first box.
Tangent of a plus b is tangent of a plus tangent of b over 1 minus the product of the two. Other questions? All right. Example 2 of that same kind, separable. Exercise 2, I mean, solve the following. Again, the exercise is always going to tell you, solve this equation, and it gives you the method, and that's the method you're going to use for it. Solve the following separable equation. And this time around, the equation is x squared y prime equals y minus x y. Y of -1 equal -1. Again, I bring your attention to what I just said. The question is about the methods that you use to solve, not the problems that you're solving. This question says, solve the following separable equation. Though this equation is linear, and I can see that it is linear, the method is saying, solve the separable equation, because this is separable as well. So I give you this problem, and you serve me the linear problem here. If it's 20 points, you get 0, because that's not what I'm asking you to do. So you need to read carefully and answer the question as asked. So when it says separable, you want to separate the variables. So first thing, separate the variables. In order to do that, the first thing you do is you replace that y prime by dy over dx. So that's x squared dy over dx equals, and here you can factor out here, you get y times 1 minus x. Then you do what we just did in the other one, send the dx to one side and dy to the other side. So dy stands, y goes down. So that's dy over y equals 1 minus x stands, x squared goes down, and dx goes up. So that's how you separate the variables. Now they are separated. Then you integrate. That gives you integral dy over y equals integral 1 minus x over x squared dx. The good thing about this right-hand side, you can split. So that's integral 1 over x squared minus 1 over x dx. And now you can find out what each of the integrals is. This is ln, absolute value of y. And that is minus 1 over x minus ln absolute value of x plus a constant.
Bless you.
Oh, thank you, sir. Thank God we are not in the same room. We could have think, hey man, this guy is sick. So now this is what we get, and we need to remember that it says y of 1 equal -1, so we need to solve for y. And we can remove that here. It's going to give you y equals this here minus, you're going to have y. To get y here, we need to take exponential on both sides. And please be careful with this because it's something that's going to show up in other things that we will do later. So you take exponential of this becomes y, and I get rid of the absolute values because I'm going to include them into this constant here. So that's e to -1 over x times, because these things are plus and minus, I just multiply when I take exponential. Why? Because e to the a plus b is e to the a times e to the b. That's the reason why I do this. There's no other thing that you can do there. So that's e to the -1 over x times e to the negative ln of x, absolute value, times e to the c. Now this is where the magic comes. E to the -1 over x, and this is e to the ln, absolute value of x, to the power -1. And now e to the ln becomes just the number you have there. So that's absolute value of x to the power -1, which is 1 over x. So this gives you e to -1 over x over x. And then this e to the c, I combine it with the absolute value that you have there, and I put that as a new constant, okay? So that's what y of x is equal to in this case. And then you are going to use the initial value. Y of -1 equals -1. So -1 equals k e over -1. So you get k equal 1 over e. So the answer is y equals e to the -1 over x times e. That's the only answer to the problem. Questions? That's it for separable equations. And the next is homogeneous equations, the 2.3. And can you please remind me the number you wanted me to solve in 2.3?
If you could do 20.
Well, thank you. So that is now homogeneous equations. And 220, that is x dy over dx minus y equals square root of x squared plus y squared. Now, if the problem already says that the equation is homogeneous, you don't need to waste your time showing that it is homogeneous. Just solve it, because that's what the question says. Solve the homogeneous problem. It is already homogeneous. Separately, I will ask a question. Is this equation homogeneous? You show that there. And separately, I will ask, is this equation exact? Then separate, you will show that it is exact at that time. But when I ask you to solve the given homogeneous problem, you don't waste the test time to show that it is homogeneous, because the question is already saying that it is. So here it is solve. And in solving, your first step is y equals ux. dy is u dx plus x du. Or you can solve that as dy over dx is u plus x. This is du, right? Plus x du over dx. So when necessary, you can turn this equation into that. In this case, you can do because you have dy over dx, so you can replace it by that. So now you would have x, plug in, you get x, and dy over dx is u plus x du over dx minus y, that's ux, equals square root of x squared plus ux squared. And now we can start. You can say x times u minus x times u, they cancel. So you get x squared du over dx equals and here, to continue solving the problem at this level with this square root, we actually need to have an assumption. So here, if you are assuming that x is positive, that's what you all did, but without saying it. You need to assume that. Otherwise, how can you get the square root out of there? You won't be able to get the square root of x squared. So the square root of x squared is x only when x is positive. But if you're assuming that x is negative, then the square root of x squared is minus x, right? Am I making sense?
Yes.
Because so that's the assumption, the underlying assumption in all those answers that I got. So here, if you do that, then it's going to be x square root of 1 plus u squared, because you're assuming that x is positive. And now you can divide by x. So you would have x du over dx equals square root of 1 plus u squared. Okay. Now, why shouldn't we worry about x equals 0 as a solution? Because the problem starts by dy over dx. Okay. So technically that's y prime. So you're looking for y of x. And that's why here you're not going to be worried about x equals 0. You don't worry about that in this case because the equation starts by dy over dx, which technically y prime, which means you're looking for y of x. If it wasn't like that and you had dx just something times dy and then something dx, then you would have to include x equals 0 as solution as well. Now, what do we do at this point? Separate the variable because that becomes a separable equation. And so when you do that, this goes down. So that's du over root 1 plus u squared equals, and then dx goes up, x goes down. Now your variables are separated. Now you integrate. So you have integral of du over square root of 1 plus u squared equals integral of dx over x. Yeah, this thing is kind of strange. Have you guys realized watching this with the subscripts? When I put this on YouTube, it's showing me, it's translating my voice into writings on the screen. I was like, oh, so YouTube actually understands what I'm saying. That was funny, you know. So that option exists there when you're watching. All right, so we integrate this thing. That left-hand side, the integral is ln absolute value of u plus square root of 1 plus u squared. And this right-hand side is ln absolute value of c times x, as I always recommend you do. Because when you do like that, you can easily get rid of your natural logs. And then you return u equals y over x. So you get y over x plus square root of 1 plus y over x squared equals cx. Or if you want, you can do more things with this.
The identity you use for the integral of du, do we need to commit stuff like that to memory?
Where?
On step 4, where you're integrating the integral of du over square root 1 plus u squared, the identity you use to swap that around, do we need to just commit that to memory?
If it shows up in a problem, we tend to think that you might know how to do it, but I tend to try not to have a lot of things like that.
Yes.
It's a table integral. So. Okay, so now here we can simplify these things and put them in the way we want them to be. So you could have y plus square root of x squared plus y squared here. And then the x comes out of it and goes with the other one equals cx squared. Such a beautiful answer. So nice. All right. And now you can see in this example, if you assumed here x negative, because of you taking out this number again here, out of the square root back, you would get the same answer actually. Any questions?
I'm not understanding how it went from the final answer to that, from the to the final answer from that previous equation.
Here?
Yes, sir.
Okay, you take this thing out. So this is 1 plus x squared plus y squared over x squared. Common denominators. I have x squared plus y squared over x squared. X squared comes out of the square root. That becomes square root of x squared plus y squared over x. This is that.
Okay, I see it.
And now you multiply the whole thing by x. Anything else? All right, so technically this is how you would handle the homogeneous equations. Okay, if there's no other question, let me look at my brother. Any other question that you wanted me to answer from this section?
So we're going over, each section is going to have at least 2 questions on it.
Yes.
All right.
Is there any problem in that section that you want me to solve? 2.3. And we go to 2.4. Questions of 2.4 that you want me to solve? Anyone with a question?
Could we go over number 10 from the homework?
Solve the following. Exact equation. And again, when the question says solve the exact equation, there is no need to show that the equation is exact. The question already says it is. And so the question here is x cubed plus y cubed dx was 3x y squared. And let me add something here. dy equals 0. Again, if the question says solve the following exact equation, then it is exact. All you need to do is solve. Step 1, you write the m's and n's. M is what is in front of dx, and n is what is in front of dy together with the sign. So that's the n and that's the m. So you have df over dx equals x cubed plus y cubed, and df over dy equals 3x y squared minus 5. That's the beginning. And now you choose the functions to integrate. So f of xy is the integral. I integrate this. Derivative is that. I integrate to get f. X cubed plus y cubed dx. And when you are doing advanced courses already in calculus, you need to know that you always put the variable of integration when you're doing integration. Don't just put the sign of integration, then the function, and you don't say what variable you're integrating with respect to. That's wrong because there are many variables. So here, the integral of x cubed dx, that will be 1/4 x to the power 4 power rule plus the integral of y cubed dx. Y cubed is a constant, so the integral of dx will be x, so that's y cubed x plus the variable of integration, which in this case is a function of y. And you need to make sure you remember when you're taking integrals, it's integrals, not derivatives. So most of the time the issues are you have a student writing integral and then putting the derivative here. So be aware of that. The next step here is take the derivative of what you got. So with respect to y, derivative of x to the 4th with respect to y. This is where you're taking derivative. So that's 0 plus derivative of y cubed x. So that's 3 y squared x. Derivative of h of y is h prime of y. Then you set that thing equal to the n that you have in the equation. So 3 y squared x plus h prime of y equals 3xy squared plus 5. And at this point, what you need to do for the next step is solve for h prime of y. And that's technically done by sending everything else to the right-hand side. So you get h prime of y equals 3xy squared plus 5 minus 3x y squared. Where do I get the plus 5 from? It's minus 5, right? And nobody says anything. You just let me go, continue putting my plus 5, man. You say, doesn't matter, man. Let him do, right? So that's 3x squared minus 3xy squared minus 5. That's it here, and that's it I repeat here, and that's it then right here. And then I subtract the rest from the left, and these two things cancel. And we get that h prime of y is equal to -5 in this case. And then the next step says you got to find h of y, which is obtained by integrating. H of y is integral of h prime of y dy, and h prime of y is -5. So that's -5y. Again, in this problem, we don't care about the constant of integration at this point because we know that we are going to add that as right-hand side. And right here, we are taking this thing and returning to put it into this formula. So we are taking the -5y back to plug in there. So get f of xy equals 1/4 x to the 4th plus y cubed x minus 5y. That's it. And then we go on step 8. What do we do on step 8, Charlie?
You set it equal to the constant.
Set it equal to the constant. Thank you. So here, right there, we go 1/4 x to the fourth plus y cubed x minus 5y equals c. Now, let me put something that I didn't write at the beginning right here. Let me say y of 0 equals 3. And I'm going to ask Ethan, what do we do next when we get here and we know what I just wrote?
You're going to plug in for x and y to solve for c.
Exact. So we are going to plug in these values to solve for c. So we are going to have x0, so that's 1/4 of 0 plus 3 cubed times 0 minus 5 times 3 equals c. So we are going to get here c is negative 15. And so the final answer in this case, after finding c, you got to plug it in here to get the answer. So you take here, you take this number back here. That's 1/4 x to the fourth plus y cubed x minus 5y equals minus 15, and that's where your answer ends. And this is the kind of problem where I tell you, once you reach this step, don't bother trying to solve for something because you're going to increase your chance of having some mistakes that are unnecessary. At this point, you already got full credit. And mostly when I create a problem like this, I want to see those steps roll out. You get them all, you did everything that is necessary there, even if you don't have the correct answer in the end. I bet you can have more than 1.5 points taken off, because everything else will just be your algebra in between and something that is completely not related to what I was trying to teach you. I'm trying to teach you these methods. That's the point. Okay. Any questions on this? It seems Trevor has a question. Or is it just a nose tickling?
What happened?
What was that?
I didn't hear what you said.
Oh, I was asking, see, maybe you had a question because I saw your finger, and then I said maybe it was just a nose tickling.
Yeah, I was rubbing my nose.
Okay. I thought it was raising your hand. So, all right. So, any other questions on this? Exact equations, the steps. Okay. If there's no question, then I will stand believing that you know what you're doing there. And if the question shows up, you're going to show me what the right answer is. And again, the right answer is the steps, not the final answer. All right. What do we do after exact equations?
First order linear differential equation.
First order linear equation. So that was 2.5, and that's the last topic of the test. First order linear ODE. And so does anyone have a specific problem that he wants me to solve of those that are in that section? I love it when I get the questions from you to solve, because I can just choose to solve the easy ones, right? Who wants to have a hard life? Yeah. Want to help me with a problem, Cooper?
Could we go over number 40?
40. Okay, I love the big numbers. But 40 is not the standard one to start. So let me solve another one before solving 40.
Can you do 10?
What was that?
Number 10.
10. Wow, it seems 10 comes like 3 times. Y prime, so there probably will be a number 10 on that test. So first problem of this section, that will be y prime equals 2y plus x squared. Yeah, plus 5 and that doesn't matter to adding those things to it. So you have a problem like this. And the good thing is you need to bring this problem to the form that is necessary. You need to have the problem written in the standard form. And the standard form is y prime plus p of x y equals f of x. No matter how the problem is given to you, bring it to that form before you start. So how do I do this in this problem, Jimmy?
Move the 2y to the other side.
Thank you. So we move the two y's to the left. And when we move it, it comes to change its sign. So it becomes y prime minus 2y equals x squared. Now we are done and ready to use the formulas for this. This whole thing in front here is the p of x.
I think you're missing a +5 at the end of the question.
I didn't write it and I say it doesn't matter because actually it's just one integral. So I have a problem 1 here. So it's not called problem 10. It looks like problem 10. It just remove the 5, right? Now, once you have the problem in this form, the first thing you do is identify that p of x. After identifying p of x, you find mu of x, which we call the integrating factor, which is e to the integral of p of x dx. That's it. So, and you write that down for me to see that you know what you're doing. So that's e to the integral of -2 dx, which is e to -2x. We don't care about constants of integration because we just need one function. Then in the next step, we multiply the equation by that integrating factor. So that's going to be e to the -2x y prime minus 2 e to the -2x y equals x squared e to the -2x. And then we combine the terms on the left into one derivative, so that is d over dx of e to the -2x y equals x squared e to the -2x. In the next step, you gotta integrate both sides. The integral of the derivative on the left is just what is inside, so that's e to the -2xy equals integral of x squared e to the -2x dx. And I do want to see some work here finding that integral. You know, it's integration by parts. So show me at least how you're doing the parts. So this is by parts in this case. And so an integration by parts states that integral of u v prime dx equals uv minus integral of v u prime dx. That's what we call integration by parts. So we are going to take this as v prime, and this as u. U is x squared, and if this is v prime, then v is e to the minus 2x over minus 2, because that's the function that has derivative e to the minus 2x. And then you go minus integral of v, which is this that I just wrote here, e to the minus 2x over minus 2 times u prime, and u is x squared, u prime is 2x dx. So you got minus x squared over 2 e to the minus 2x. Minus and minus, that's plus 1/2 integral of 2x, 1/2 and 2, they cancel. So that's just plus integral of x e to the minus 2x dx. So right here, that's just x. And now you do this again by parts. So this is e to the minus 2xy equals minus x squared over 2 e to the minus 2x. And then the integral, here again, we take u here and this as v prime. And that'll be plus u v, so that is u is x, v is e to the minus 2x over minus 2 minus integral of v, that's e to the minus 2x over minus 2 times u prime, and u is x, u prime is 1, so that's just dx. And now you get e to the minus 2xy equals minus x squared over 2 e to the minus 2x minus x over 2 e to the minus 2x and then minus and minus here, that's plus 1/2, and the integral of e to the minus 2x is e to the minus 2x over minus 2 plus a constant. And that gives you, and I can factor out e to the minus 2x, so that's minus x squared over 2 minus x over 2 minus 1/4 e to the minus 2x plus a constant. And now what you do is you divide to get y. That last step. And when you divide, e to the minus 2x cancels with the e to the minus 2x, so you get negative x squared over 2 minus x over 2 minus 1/4 plus c e to the 2x. That's it. And you have, if you have initial values, you plug them in to find c. Questions? Okay, so that's it. And again, I emphasize, and you need to understand the steps that you use to solve the problem. That's very important. That's what I'm testing you on. That's what I'm trying to teach you. So don't look at the problem itself, look at how you are being asked to answer the question. Review whatever we have done. These are the only types of problems that you have on that test. There are 4 of them, and I happen to believe always that this is actually the easiest test of this class, but because most of the time people don't follow the instructions on the first test because they always think that we can get around with it, but you try to get around, I'm going to tell you you were wrong. And you'll be late on the first exam to do after that. So please follow it. And then you'll be, just as you see, 1, 2, 3, 4 problems. Here are the steps. I'm done. 100. And apart from the 4 questions that you have on the methods, I will ask you 2 other questions. One is show that the equation is exact, and the other question is show that the equation is homogeneous. That's it. That's all you have. Okay. So the last thing on that test is going to be question 5. Show in 2 parts. 1, show that the equation is exact. Either show that the equation is exact, or the question will ask you, is this equation is exact, right? Is this equation exact? And it's not asking to solve. Is it exact? You do what we do when we want to show that the equation is exact. Saying dm over dy, is that equal to dn over dx? That's what the question is. That's what you need to do when you have that question. Find derivative of m with respect to y. Find derivative with of n with respect to x. If they are equal, then the equation is exact. If they are not equal, then the equation is not exact. Say, for example, here, x dy minus x sine x minus y dx equals 0. I still have your problem 40. I'm going to solve it. Okay. And so this is actually n, because that's what is in front of dy, and the whole thing here is m in front of dx, and then dm over dy equals 1, right? You see that? And dn over dx equals, oh my God, 1 also. So just looking at it at the beginning, it seems strange, but actually they are equal. And when they are equal, the equation is exact. That's it. Exact. Exactly an exact equation. And the part 2 of that question would be show that the equation is homogeneous, or Is this equation homogeneous? Any answer of the kind yes or no is worth 0 points. You need to do the work to answer the question. And the work is, if the equation is m of xy dx plus n of xy dy equals 0, then you want to make sure that m of xt yt is equal to t to the power n m of xy and n of tx ty equals t to the power n n of xy. If that is true, then you conclude yes, the equation is homogeneous. That's it. But if you don't do that work and you just answer yes, I put a smiling 0 there and I move on. Now let me solve. Let me solve problem 20 and 40. He asked me problem 40, so problem 40 it is. So dx equals 3e to the y minus 2x dy. And this type of problem is to make sure that the student understands that an equation can be linear in x also, not always in y. He needs to look for a linear equation. So your equation can be linear in x. In y, it's impossible because you can see e to the y. So you can't make this a linear problem in y. So you got to make it linear in x. So that is dx over dy plus 2x equals 3 e to the y. Oh yeah, great. Now that's a problem that is homogeneous, that is linear, first order linear in x. That gives you x prime plus p of y, x equals f of y. So the equation just flips. And now the function you're looking for is x of y. And that's one of the types of problems that we have. There's someone I'm putting in, but it keeps getting out. Okay, and so right now it's already in a standard form, and so this is p of y because we are solving the problem that is linear in y. So technically that's exactly as you have on that test. You have one problem that is linear in x, you have another one that will be linear in y. So here we find mu of y because the problem is linear in x. So mu of y is e to the integral of p of y dy, and that is e to the integral of 2 dy, which is e to the 2y. Again, we don't care about the constant. Next, we multiply the whole thing by mu of y. So we get e to the 2y dx over dy plus 2e to the 2yx equals 3 e to the 3y, because e to the 2y times e to the y is e to the 3y's. And then we combine. This gives us d over dy e to the 2yx equals 3 e to the 3y. Then we integrate. The integral of the derivative is just a function that is inside. So that's e to the 2yx equals, and the integral of this is just e to the 3y, but you don't forget you have a constant of integration. And now you can divide by e to the 2y and get x of y equals e to the y plus c e to negative 2y. That's it. And
Okay,
so
so-
you say perfect. Yep.
All right, so the part where it says multiply, it says plus 2 e to the 2y. Where does that 2 actually go? Like,
It doesn't go anywhere. We're combining these two to get that. That's one of the steps. And the reason why you found the integrating factor was to make sure that the left-hand side is what we just wrote here.
okay.
Are we good?
Does it matter if we put like x to y or like y to the x equals?
That's not y to the x. This is x of y, function of
Or
y.
x,
Just
that's
as you
no
write
problem.
y of x. This is not y of x, it's x of y. X as a function of y, that's a function of y. That's why you got x of y.
Right, but like the question you did before that on the first order linear, like you just put y equals, like it is either. I know like there are two different, like you're doing two different functions, but like on the problem before that, it doesn't matter if we just put y or y of x.
It doesn't matter. Even here, I could just write x. I'm just emphasizing that it's a function of y. There also, I could write y of x. I thought you were switching things here. Mhm. So it doesn't really play any role. You can just put this to emphasize that you're giving this as a function of y, or you could, in the previous problem, as you're saying, you could write y of x instead of y just. That would be right. Anything else? We have 3 minutes left. So ask me a question for 3 minutes. I see somebody smiling. Is that a question coming? Some people actually didn't submit their homework, and I find that strange because you're choosing to score a 0 out of 25 on an assignment. And usually it is hard to have points in this class. You don't want to be doing that on a homework. All right, if you don't have any questions, then I'm done, and I'll say good luck till Thursday. Thank you.
Thank you.
See ya.
Thank you.
Welcome, sir.
Thank you.
I'll see you. You have a question, James?
Yes, sir. One last question I had was, so you had the questions where we needed to show that the equation was exact. When we